But if you imagine a cup of tea, all of us here, I guess, like their tea slightly different, some stronger, some weaker, some sugar, some not. And you've got 4 ingredients: water, milk, tea and sugar. And whatever way you put those, you can mix them to make your perfect cup of tea. And the formulation is quite similar in the fact that we optimise it for turf. This is a turf formulation, and Alex is going to explain how we take an AI and make it that it's absolutely perfect for turf, so it does exactly what you want it to do for your specific situation. So yeah, pretty much Alex is going to go through that. Ask any questions as you go through, and all yours.
Hi, I'm Alex Bassett-Cross. I'm a scientist based at Gellets Hill. So it's in Berkshire. We've got a research centre. Any questions, just stop me through. I'm running in a general order. There's no, any questions at any point, so be fine. Okay, so
turn to the first page, I guess, was probably the good start.
So we've got 2 research centres. One's based in Stein and one's based at Gellets Hill, and Stein's in Switzerland. And what they do there, we've got scientists and lab coats, organic chemists, and they will basically look at pests. They will have tried new active ingredients out, they design them, they make these chemicals, and then they screen them in glass houses or in fields or whatever, and then they come out with something that works on a pest, so powdery mildew or insects or whatever it happens to be. And that's where formulation really starts to get involved in, because what we get delivered is some nice powders. We like powders. Powders are quite good. We can do a lot of things with powders. We get liquids, nice liquids. You can do a certain amount of things with liquids, but it's good. Sometimes you end up with a gum, and it's sort of, great, what do I do with that sort of thing?
So what situation would you be given one of those?
When someone's done a poor job. So propiconazole is very similar to this. Anybody know?
Okay, so that's Vanamax, one of our products.
So propiconazole, it comes as a viscous, really viscous liquid. Thing is, you can still do it, it works on it. It just means it's challenging for us we've got to think carefully how the products we're going to design with it, and we've also got to think how we handle this on a manufacturing scale. So okay, here I can put this in the oven, warm it up to 40 degrees, and it's very mobile, liquid, it turns like that, and then we're great, or bilio. But if I got 10,000 litres of that's a different challenge.
Yeah, and also, we sell it into Canada, which is in some places very cold, so it's very difficult for us to be able to...
Inherently, it always will be like that, but we, as formulation, we try and change it and try and make it more usable. So, and any of these here, you put them in a spray tank and they're just going to sit there and they're going to do nothing. So we have to get this in a formulation that you can use in the market, and then actually works on your turf in this instance. So today what I'm going to do is I'm going to talk you through developing an SC, which is a suspension concentrate. So if you flip your page over, there's a sort of guide there. So, and that will upside down, Daniel.
Oh, right.
And it just basically says, this is a sort of guide. It just says, look, we've got a solid or we've got a liquid. What products can we make out of it? So what you can't do, and we have tried this, is to make a liquid into a solid. It's not impossible, and we've tried before and we haven't done it yet. But with a powder, you can do a lot of things. So you can make a granule product, or you can mill it, and that's what I'm going to talk you through. Make an SC. It's where you reduce the size of the particles, and then you can make a liquid formulation. So a suspension concentrate basically is the active ingredient is ground to the size that we need to know what size it is. So for turf it might be smaller, for wheat it might be bigger, but we will know that from our research and our understanding over the years, and we'll grind it to that size, and it will be suspended in water, and so you end up with a nice product. So first of all, what I'm going to do is I'm going to put a bit, the wind's picking up, I'm going to put a bit of my powder in here and then demonstrate why we formulate. So, do you want to give that a shake? So, it doesn't like water. It's what we call hydrophobic. It just sits there on the top. It's used to no one. We can't do anything with it like that. You guys can't do anything with it like that. This is all sitting at the top. So first of all, the first thing we need to do is we need to get this powder into the water, because if it's sitting on the top, we can't process it. So we will add a bit of something called a wetter. So this will just basically allow the product, the AI, to go into the water. I'm going to give it a shake again. Yeah. As you can see, it started to go in. We better shake. It always likes to be together. So you see, it started to go in, we started to see something going in, and it's starting to settle on the bottom, which we didn't have before. Shake it more, it would happen more. So now it's in the water, we got to, because we're milling it, and I'll step into some detail about milling in a minute, it will always like being back together to itself. So what we need to do, we need to try and make sure when we've got these particles to the size we want by our milling, that they stay apart. You know, they're at the right size we want them for the turf or ornamentals or crops or whatever we're looking at, and it stays at that size. So if we mill it, it breaks down and it joins back together again. Okay, it may be particles, small particles make a big particle, but ultimately what sits on your leaf would be a big particle. So we need to keep them separated. So we use dispersants. So today, dispersants can be powders, they can be liquids, so they can be nice liquids like this. So today's demo I'm using a liquid, but they can also be quite viscous like that. Again, it's a handling issue because it is very viscous, but you know, we can heat it up to 40 degrees and we can use it. It's just a different form, but as you can see, they're not nice and easy things to add to a product, and we have to spend time understanding them, handling them, and then processing them, because we're not only just doing it in a lab. At the end, we have to make this at scale, 10,000 litres, 200,000 litres, to make products to sell in the market. So this is my dispersant. So this dispersant is going to keep your particles apart when you've milled it. So I'm going to put a bit in. So this really you won't see a lot of this because we've got obviously not going to mill. Do you want to shake it again?
So you would keep trying different amounts of each of those to get it to disperse to the right amount based on what you want to do.
Yeah, it's in conjunction with the milling step. So we're going through this. I'm doing it really crude here, but we have the robot here. It's a couple of multi-million-dollar robots sitting at Jertshill. So this will do sort of this size test formulations, and it will do thousands a go. So we will take the active ingredient and it will screen through, and we use that as our first pass sort of thing. Goes through, and then it will come up with some crude hits, and then we'll refine that in the lab. We'll get in the lab with those crude hits and then refine them into a better product. So we're skipping on a bit in this book, but basically we've started to get foam. So for us, this is a big problem. So, you know, we've got a bit of foam here, and we've only given it a light shake really, whereas if you're mechanically grinding it, you're going to get lots of
if you
foam.
look at this page with the nozzles, and you can obviously see what some people have occasionally seen in their tank. So we're trying to avoid this particular bit where you get that, you know, when you're on site.
So foam for us is a big issue. Foam for you guys is a big issue. So you don't want it in your tank foaming out of it. We don't want it in our manufacturing because we put lots of energy into this when we're making it, so it's going to foam like hell. So we have this thing called an anti-foam. This will suppress the foam. Things that you might see in the normal market at home is Infocol for children. So any of you had children, Infocol is an anti-foam for children. So when children drink their milk from their bottles, they get a lot of foam and trapped air. They put a bit of anti-foam in and it suppresses the foam. And you're going to see that sort of effect here. So you just put a couple of drops in.
It's amazing how quick this works, isn't it?
Yeah. And it just collapses. It's just all the foam sort of collapses, and it's all gone now within seconds. Me talking, and
that's already you see on the market people sell at the anti-foams that people spray in the top, but with all our products it's built in.
It's all built in. It's built in for two reasons. Again, it's for us mechanically, for our point of view, we don't want it in our factories, but also you don't want a product foaming. It's just poor. It just shows no one put any effort into designing it at all. It's just, you just wouldn't get away with it. So as you see, I've been shake as much as you want. It's never going to form a foam again now. So there we are. So we now have a solution with solid particles in there, which are just as they came, with dispersants, with the anti-foam in, and a wetter. So now I can do something with this. So I'm going to mill it. Well, I'm not really going to mill it. I'm going to tell you about milling. So milling, so obviously I've talked to these events before, and I've talked about milling, and people are like, well, what's milling? What do you do? And I thought I'd bring some beads today to show you. So you imagine this is my milling chamber, and these are the real beads that we use. Okay, so you get different sizes, but this is the average sort of bead size we would use to mill this product. And inside here you'd have sort of blades, circular blades that would rotate like that. And basically all these beads would be all churning around, and we just basically pump our formulation through, collect to the other side, and then we will measure the particle size. And then if we need to do it again, we'll loop it back through again and that. So what happens is you're in the mill, as the beads are all moving around and your AI is getting forced through, it crush, they smash, they all break up, and they come apart as you shattered them. But because you've got dispersants in there, they coat the surface of the particles and they just repel them away from each other. So it's a way to describe that in a way would be like if you've got oil from your frying pan, you put it in the sink, you put a bit of fairy liquid on, and they all disperse, you know, breaks up that. It's a similar sort of effect, you know. In that case, you've got your fairy liquids coating your oil droplets. Here I've got my dispersant coating my solid particles.
So I think the sort of like understanding or expectation is that the AI would come milled at the right size, and then you would add it to the stuff, but actually you're milling it once it's already in solution, and you're milling it to the right properties you want for turf, I guess. So if it was a different crop, it'd be milled differently, but you're getting it to make sure that for you guys it's perfect.
So my team, we've got loads of projects on the moment. We're working on a mosquito product at the moment for malaria, and it needs so mosquitoes pick these up and they groom them in, and so they need they need big particles. So it's about size 12 microns, so it's big. This would typically be between 1 and 2. So you can even if you don't know what a micron is, you can think if you've got size 1 to 2 and you've got size 12, if you're talking centimeters, that's huge. So there's a big difference between. So we optimize it purely for the turf products. Okay, so now you can see it's milled, it's lovely, but we live in a world where gravity takes effect, so everything always settles to the bottom. So again, we can't sell you, so we couldn't sell you something that foams, so we now can't sell you something that settles out, because we know that you will have these products on your shelf for, I don't know, 2-3 years, maybe 4 years, whatever it is. And if you came after 3 years, you want it to use it the same as you did on year 1 or month 1 after you bought it, and you don't want to be having to get to a pack to shake it up, stirring it, you know, all sorts of stuff.
Primo's a good example. I guess with Medallion, you'd probably put it all in the tank and you'd use it in one go, whereas Primo is something that you'd come back to time and again, use a little bit, use a little bit more, and then just keep applying it. So that's a really good example of how we need to make sure that it stays in its proper form from start to the time you finish the product.
So what we do is we put things called anti-settling systems in. So this one's a clay, and it's sort of jelly-like and quite gloopy, but as you can hear, you shake it, it turns very liquidy. And so this one's particularly is a clay, and what it is, it's plates, and they're flat discs. And what they do is they form a house of cards effect. And basically they pack sort of like this structure, so if you're balancing cards on one another, and they create a sort of matrix in your bottle, and then with all your tiny particles, once they've milled, they all sort of get trapped in there, and you get it there. You have to optimize this, because obviously it's too thick, you don't want to be going in your can, shaking it to get it in your tank, and likewise we need to put enough in for it to keep everything up. Other ones we use are, it's a bit like, to use one that you may know, is like a gelatine sort of style ones, but the problem with that, all our anti-settling system is bacterial contamination. So if you get bacteria in the processing plant, or when you're repeatedly opening your bottle in field use, it will eat that, and then your formulation will fall out of the bottom. So A, you don't want mould in it, and B, it has a physical effect on your thing. So you basically end up back at this situation. Once it's consumed it all, you have a nice mould on the top, or pink colour sometimes the formulation, and then all your AI collapses to the bottom. So what we do to stop that, we put things called preservatives in. So salt and lemon juice is what you'd use preserving food. We use ones that are powders and slightly more technical and definitely not edible. So they come in powder forms, liquid forms. I'm not going to add it in because it won't help benefit show you anything, but basically everything has a preservative in when you've got a nice juicy thing that it wants to eat. It keeps plant hygiene there, so we know we don't contaminate any other products when we're making them in the plants, and it also keeps it there, so when you always go back to your bottle, you shouldn't have any bacteria in it. I say shouldn't, caveat. Right, so once we've now got a formulation which we sort of screened and tested in the booklet, it will show you some of the equipment we use to go and test with. There we go, with the tractors on. So a lot of people go, oh, you just do it in the lab, you don't know about real life. So we really have tractors, we can drive a field and spray it ourselves, but we actually use the equipment you're using to test that this works, applies. You don't put it in your spray tank, it doesn't settle at the bottom, it doesn't sit at the top, it's to block your nozzles. We go through that whole process.
So you've made the formulation and your team has done that, but then you go and work with the guys who are putting it through the sprayers, and then actually you can then refine it backwards and say, okay, we thought it was good, but it doesn't work in this situation, we'll keep refining it to make sure that
goes back to
your situation until basically everybody signed it off to say from all applications it works perfectly.
Yeah, and that's the idea. So that's why we look at the application. We send it to biologists to test in the fields. and stuff, and glass houses, so we know that the effects we want, we're seeing. So we go through this iterative process, keep going backwards and forwards, and sometimes we may say, Daniel might come in and he might say, well, actually, we're operating in the autumn season in the UK, it needs to be rainfast within 15 minutes. Is there anything you can design in there to help that? So we may put adjuvants in there, stickers, wetters, fungicides. Fungicides can be a contact fungicide, they may need to be a systemic, which means they need to penetrate. We need to get it in there. So we will look at adding adjuvants in to help it perform, get the best out of your bacteria. All formulation are doing, we've got something that really, really works, and we're just trying to maximize that when you use it, you get that near enough 100% out of it.
That's a good example here. I guess we've got some of the products. So you've got Medallion, which is a contact fungicide, so you really want to get that to stick on the leaf. So Alex and his team will design it to make sure it sticks as well as possible, whereas maybe the Heritage WDG is something where if you want it for some fairy ring control, you want to maybe get it into the soil, so it's designed so that then you can use it in slightly different ways, and every one is optimised. And I guess you're going to talk about the difference between some of the Primo Max and
we'll do a little demo with them in a second. So we look to build adjuvants in, so if we need an adjuvant or an additives added, then we will build it into the formulation. Sometimes it isn't possible, things in life like that happen, so we will recommend on the label that you do. If on our package we say an adjuvant, if it doesn't say you need an adjuvant, you don't need it. And generally our products don't need adjuvants, they're either built in or you don't need them. So what I'm going to do now, if you've got no questions about the SCs, we're going to talk quickly about two other products. So you've got Primo Max, and I've got a non-Syngenta branded bottle of Modus. Same AI, same sort of formulation type. So basically this one's an MEC, it's a new newer technology, and then this one's an EC, a very good older technology. And basically what happens there, we take a solid powder, well actually it's Trinexapac, isn't it? So the Trinexapac is a sort of a waxy crystalline material, and we will dissolve it in a solvent. We add some what we call emulsifiers. They're basically dispersants, is a different name because it's a different product, but it's basically the same. So the idea of that is when you pour your oil with your AI dissolved in it in your spray tank with these emulsifiers, they form droplets. And the key thing about these two products is that droplet size. One is optimized purely for turf, one is optimized for wheat, and it's droplet size. So what we're going to do is we're going to demo the two now, and then just talk a little bit about that.
That's one of the things I think I want to help the station get over, is the fact that the Primo Max and the Max Formulation is designed specifically for your situation. So you know that you're using it to get the absolute best out of the product in your specific situation. I think it's a really good example here. You can see the difference.
Okay. So I've added my EC, which EC stands for emulsifiable concentrate. It's in your brochure, it goes through it all, explains it a little bit. And basically here I've got my nice milky solution you might be familiar with. It's milky because of the size of the particles bigger, and I will go through when we talk about the MEC, and light hits it and it refracts and it basically gets a white light, or you see a white product. With our MEC, when we add that in, I'm sure Daniel loved this when it first came in the market, demonstrating this, when it looks like you've got actually nothing in your tank at all. How do you explain that one, Daniel? So, and as you're all familiar, you put that one in, it's clear. Now, there's the only way I can think of describing the size difference. This again is emulsified droplets. Again, it's tiny droplets. If I put this under a microscope, you would see the droplets under a microscope. If I put this one in, you wouldn't see anything, because it's still droplets. It's just the size difference. So, I suppose the way of looking at it, this would be like beach balls, and then this one will be like what do you call them? It's a tiny little marble or something. It's a massive order of magnitude difference in size. And so when light comes in, passes through this container now, it's passing past these particles and it's not getting disrupted. So you basically see that.
But so for turf, that's going to be way better in terms of getting it much more even across the leaf, much more better into the plant, and much more optimised in terms of how the plant's ability to take it up.
Yes, so if you think for a turf leaf, it's so wheat or barley is a grass as well, broadleaf, so you've got more areas to splash and hit. Turf is smaller, it's a more dense foliage, so you want all these tiny particles splattering all over it and absorbing on the surface, more over the surface all over the place, whereas on wheat you've got a bigger target area, so you can use an EC and smack it, and it's more chance of hit contact and hitting it. I mean, you don't get the max formulations in crop protection. It's specifically designed for turf because of the research we do in understanding turf products. I mean, in Stein we've actually got plots with grass laid, and we test our products on them, and so we really do go into all the depth of understanding it, and then this whole cycle goes backwards and forwards. Let me go around.
Benefits, just one question. The major benefits for these guys between the two different formulations is, I guess, grain fastness. Yeah, and the amount of product you can potentially get into the plant and how fast it goes into the plant.
Yeah.
So better effect from the max formulation compared to the EC formulation.
Yes, for turf. Yes,
Yeah.
specifically for turf. You can't always deliver this product, so this will only work with a limited amount of AIs in a certain thing. Right, you know, as you see.
Yeah, Heritage Max, and so is oxystrobin and the Trinexapac.
So you can't say, well, I want this one and that one and all these ones to develop to this, because it can't always work for that. It's great technology, but it is limited from what you can put in them. EC, again, limited what you're trying to dissolve something in a solvent, so it's like, imagine dissolving salt or sugar in water, putting sugar in your tea. You can only get a certain amount in there, you can't overload it, and that's where we are. We are also, so when we design these products, so we're almost there, but we've now got to register it in a country. So we're talking about register UK, we talk about Scandinavia, we might be Egypt or wherever they're growing grass, they want to use this. So we will put these products in, and we will store them for 2 years to check that they are stable at temperatures in 2 years. We're recycling ovens, so we have ovens which move between 5 degrees up to 40 degrees, or they might cycle between freezing and minus 10 to 20 degrees, so you've got it going for a freezing period. So we know that this product, when you get it, it will stay, you won't see separation in it. You may get a little bit at the top on some of the SCs, but that just naturally occurs, but you shouldn't have crystallization in it. It should be fine, it should be stable in the temperatures you operate in, and also the products, what we use, the range of things we use, also depends on where we're going in the world. So for example, Europe's quite highly regulated, so we may not be able to use this product in our formulation, but we can use an alternative one, and then we go to another country, we may not be able to use that in another country. So it's a bit of a balancing act. We're knowing the regions of where we're selling, the regulations, what we get from the technical managers who say, right, in this specific market we want this. Also there's customer perception sort of drives it as well. Some crops, they're used to certain markets in Japan, they specifically like certain types of formulation, and then you have to design a formulation that suits their market, because if you come in with something new, no one's going to buy it.
Yeah, no, we see that a lot in our kind of pest business, is that especially rodenticides in Ireland, they like a pellet form, but in the UK they just won't use pellets, don't like them, won't use them.
They use the nice
just
blocks.
Personal preference sometimes.
That's a driver as well. Other things we do, we go, so there's a market bit, and we also go make sure we know you don't buy everything. It's not all Syngenta. Syngenta doesn't make everything. You use our product with other products, you use it with some of our products. So we will go extensively, before we go to market, we will test it, and we will tank mix the 2 or 3 way mixtures with these, and check that when you're in your spray equipment, when you're there, you have the confidence that if Syngenta says this is compatible, it is compatible with those products, and you're going to end up with some sort of curdled soup of a mess that you're there with a little brush trying to clean out your expensive nozzles or filters and blowing them up and trying to get the muck out at the end is horrendous. Yeah.
I think one of the things, you're absolutely right, I think one of the things I've learned, from this morning is that with the Syngenta products, although they are, at the top end, you get everything built in. The whole thing is designed. You don't need to add additional stickers. You don't need to add additional, anti-foamers that, basically you might need to buy in other things. Everything's in. It's all done, literally ready for your crop, for your plant, ready to go. Which is, I think, difficult maybe in Nick's situation, Nick, to really show the value of the product, but actually all of it is already in there, and it's all built in by you guys to kind of make sure that it's absolutely optimised.
Yeah, it is, and that's the idea. We just want you to have one can, you go and put in the tank, and that's it. You want to be able to go backwards and forwards to reuse it if that's how much where you're buying it, if that's what you're treating your acreage size is. It should be an all-in-one system. I suppose it's like buying an iPhone and not having an operating system on it, or not having a charger. You buy your iPhone, you expect those things to be there and to be able to use it, make calls and do things, and that's what we do. The information